Welcome to the next video in the group theory series. In this video, we'll be discussing the group of units. Here you can see a preview of everything in this video, so you can decide if this video is what you're looking for. Okay, we've already seen one example of a group of units actually. This is the example of the nth general linear group for just about any number set. Recall that the set x to the n cross n with the operation of matrix multiplication did not form a group only because not every element had an inverse. So we just formed in a previous video the subset GL sub n of x called the nth general linear group, which is a subset of the set of all n by n matrices. And it's that subset which does have an inverse, and that turned out to be a group. A group of units is formed likewise from any set and operation x and asterisk, which satisfies associativity and identity. We then define x in x such that x inverse is an element of x to be a unit, right? So what that is saying is that something is a unit if it has an inverse in the set, right? So units are things with inverses. We then define x cross, this cross symbol, to mean the set of all units in x. And this will be the group of units. Naturally, the operation on x cross is the operation on x restricted to this subset, the subset of the set of all units. We will continue to write the operation with an asterisk or just concatenation, not respecting the distinction between the operation defined on the broader set versus the operation defined on this smaller subset, potentially smaller subset. The most important application of this for us will be the group of units of z mod n under multiplication. Henceforth, we will write this as z mod n cross and assume that the operation is multiplication. Of course, 0 is never going to be an element of the z mod n cross for any n greater than or equal to 2, right? Z mod n is only really interesting starting at 2. But we will have that 1 is always an element in Z mod n cross. And the remaining elements are all kind of something we'll discuss later on. Okay, so I have so far claimed that it's a group, but it's probably a good idea to go ahead and give the proof. So let's take any set X with an operation asterisk that has an identity and is associative, and let's prove that its group of units is a group. To check closure, we need to take any two elements that are in X cross. We need to prove that their product is also in X cross, which means that we need to prove that its product has an inverse. Now, in a future video titled Basic Group Theorems, we will see that, in fact, GH inverse is always equal to H inverse G inverse, provided that these inverses exist. Now, those inverses do exist in this particular setting because G and H were selected from X cross, and X cross, by definition, is the set of all things which have inverses. So, essentially, depending on this theorem to be proved in a future video, this proof is complete. Next, we check identity. Now we know that X has identity. We'd like to make sure that X cross also has the identity Now, of course, right, one inverse is always equal to one, and the argument for this fact is extremely easy, so you should go ahead and give it yourself, but certainly that shows that one is in the group of units always. And then when it comes to inverses, there's basically nothing to check because x cross has inverses by construction. Quod erat demonstrandum. I would just like to briefly, just because it's kind of a silly little application and also very brief, consider the group of units for the integers. The group of units for the integers, the set of all things that have multiplicative inverses in the integers, is just -1 and 1, right? Of course, 1 is its own inverse. -1 turns out to be its own inverse under multiplication. No other integer has a multiplicative inverse. So this is a mostly useless object. We won't talk about it pretty much at all. It's also now a somewhat more interesting example is the rational numbers. So Q cross, that is more interesting. That turns out to everything is a unit with the sole exception of 0. And the viewer should prove it for themselves.